everyone. In this video, we are going to talk about SPARQL language. So I guess this is one of the most interesting and important component of this knowledge modeling and semantic web technology course. This is because, so until now, what we have done, we have talked about the framework by which we can represent the data about the world in a very formal way, right? And we know that the formalism that we have talked about is resource description framework, right? So with the resource description framework, what you can do, you can create a knowledge base. So you have a knowledge base which you have created using RDF, and this resource description framework or RDF knowledge has got two parts which we have discussed. One part is RDFS and other part is RDF, right? So RDFS is basically talking about the terminological knowledge of the domain, and RDF is talking about the assertional knowledge, the concrete knowledge about the entities in the domain, right? So we know that there is a framework by which we can create the knowledge about the world, right? So why we are doing this? Basically, we have got some outer applications. We have got the applications in the other end, which will have queries, and these queries will be put to this knowledge base. And what this knowledge base will do, it will try to find whether it has got answer to this query. And if it has got the answer to the query, then it will create a set of results, and these results will be sent back to the client application, right? So as we know that this is the very structured data, so we are in the domain of structured data. It's not like a document which is human readable as we see the documents on the web, right? So we are talking about very structured way of representing the knowledge about the entities. And as the data is structured, stored in a structured way, we can write structured queries. So this is where we are deviating. I'll not say deviating. We are making progress from unstructured query to structured query, right? So if we talk about the web in general, you can write, say, one query which is a kind of a bunch of few keywords, but here you can ask precise queries, right? So you can write much more complex queries, right? And these queries will now come to the RDF database, and database will give you the answers if it has got any, right? So in this particular part of this module, we'll be talking about the constructs or the structure of the SPARQL language, right? So I'm talking about this SPARQL to be one language, right? So we are just saying it's a language. So it's basically a query language, right? But on top of that, it is also a protocol. So it is also a protocol. So protocol for what? So as we are working in a distributed system, so the client is situated in a different server. So this query which has been written in a particular language, that has to be transferred to the RDF database where the database is hosted, and then the result has to be somehow packaged in some way, and then this package will be sent to the client end, right? And this particular protocol is defined using this SPARQL, right? So this SPARQL is not only a query language, but it has got a protocol part of it, right? So we will talk about the protocols a little bit. So basically we rely on HTTP protocol. So whatever we'll be doing, the query and the responses, they will be transferred by this HTTP protocol. But there is a structure, right? So before moving to the details of the language, let us try to have a very bird's eye view of the language itself, so that we know that what are the things that we are going to discuss, right? So So if you look at SPARQL, SPARQL is a language as well as a protocol, right? And what does this protocol support? It supports remote query, right? And this protocol is really a basis for something what we call as SPARQL endpoint. So this is a very important terminology for us. SPARQL endpoint. So what are those? So basically, when we design or create one RDF database, so the only way to expose this database to the outer world or publish the data that you have with you in RDF form is to do with the SPARQL endpoint. So you create an endpoint which will be queried remotely. So these endpoints are called SPARQL endpoint because they support data access through SPARQL, right? And also this protocol supports programmatic querying. So for example, you know that there is a SPARQL endpoint and you want to query the SPARQL endpoint and you want to do that through programs. So for example, you can write a Python program or a Java program, and from the program you can write a query, send the query to the client server end and receive the answer and then do further processing, right? Now, SPARQL queries, so if you take a SPARQL query, it has got different types. I think the most widely used type is a select query, right? So, for example, you want to know, say, the companies and their CEOs. So, you know, there are details about different companies and different CEOs and different persons in, say, one SPARQL endpoint. And from that, you want to query somehow, you want to represent the query somehow and want to get the information about the companies and their corresponding CEOs, right? So, here what you are doing, though, the company representation of the company in that database has got many more attributes, right? So from that you want to select only company name and the person who is CEO, though it may be having location and other things. So what you are doing, you are selecting a subset of the attributes concerning different entities, and these attributes you want to have for those you want to have the results, right? So these kind of queries are called select queries, right? The queries can be of ask type query. So these ask type queries will give you a kind of yes no result, right? So you can say whether Mahendra Singh Dhoni is a captain of Indian cricket team, right? Or Virat Kohli is the captain of Indian cricket team. So this is a ask kind of query. So sometimes what you can do uh, as an application, you want to harvest the data in triple form from the other data sets or the other endpoints. So this might be required for many scenarios. For example, maybe you are one aggregator, right? So you want to provide a kind of unified view of different SPARQL endpoints to the other entities, other third-party applications. So in that case, what you want to create some triples or harvest some triples from other RDF endpoints or SPARQL endpoints and store those triples at your end. So there you are constructing a triple, right? So these kind of queries are called construct queries, and then you have something called update queries. So let's say you have one SPARQL endpoint and you want to delete some triples, or you want to update values of some triples. So for example, this if you take this COVID-19 scenario, so Wikidata maintains the daily counts in different countries for different countries. So there they have a triple like say country, daily say new cases and a value, and you know that this value changes day by day. So in that case, they have to update the database as the new information is coming, right? And that can be done through update queries. And you see this update query for our update query, you have to have the right access to the endpoint. But for the others, like select, ask, and construct, you just need to have this read kind of access. right? That the most important component of a SPARQL query is the where clause. So this is a kind of core of a SPARQL query, right? So in where clause, what you write? You write basically a set of constraints. You write a set of constraints that you want the results to be satisfied, right? So you don't want all the results, all the information from the RDB database, but you want to put some constraint, and that will restrict the result that is coming to you, right? So how this where clause can be specified? This where clause can be specified using graph pattern. So in the introductory lecture, I have shown you a very basic structure of a SPARQL query. So there you have seen that the constraints that we are putting, they are kind of looking like a graph. So that's why these are called graph patterns. So these are kind of templates, right? So these templates will be having variables, and so you can think of it as a graph, and some of the nodes in this graph, they are having a kind of variable. So these nodes are variables. So these variables, they have to be filled in, and whatever value you can fill in, they will be acting as your result, right? So the most simplest way to represent this graph pattern is called the basic graph pattern. So it's basically a bunch of triples. So for example, one triple or multiple triples, right? Now this triple may contain something called path pattern. So this path pattern is also a very interesting thing. So for example, you have a social network data, right? And you want to know that who is, say, you define a friendship relationship. For example, someone uh, who is connected to other via three friendship edges, right? So you see, you have a path here, right? So you can encode these paths or the patterns of these paths in the query, right? And they will be giving us very interesting results, right? The next group is what we call as a group graph pattern. So you can have multiple graph patterns and you can group them together, right? So it can be a group of basic graph patterns, right? Another interesting way of posing the constraint is what we call the optional graph pattern. So whatever graph pattern is coming under this optional tag, they are not like hard constraints. So you can pass on the results who are not really satisfying these graph patterns, but also you are passing the results which are satisfying these optional graph patterns. So they will give you a set of alternatives, right? Or model alternatives. You have something called union graph pattern, right? So this union graph pattern, by the name you can guess that it is a union of results that you get out of two graph patterns, right? So it can be union of two BGPs, or you can be union of complex graph patterns also. Now, finally, what we have is called a graph pattern, right? So it is a graph pattern, but you want to include other graphs in the graph pattern. So this is a kind of involved concept. So this is required in the sense that, let's say, you have multiple endpoints or multiple graphs you want to query, right? Now, how do you query those? So it is not a single endpoint. So you want to say that these are the graphs I want to query, and there we can play with which graph to include in my query, which graph I need to exclude, and all those other things. So they will create a graph pattern also, right? And this graph pattern is relevant to implement different things. So one thing is you want to achieve, say, modularity. So you have a very huge data set and you have to store the data sets into fragments, and each fragment will talk about a particular aspect of the entire graph. For example, let's say you are creating a data set for sports domain, right? So you can have a subgraph talking about, say, cricket, a subgraph talking about football, subgraph talking about tennis, and so on and so forth. So it can handle modularity. There is something called provenance. So this provenance thing we have talked about in the introductory lecture. So whenever you are publishing a data, whether your data will be used by others may depend on how much trustworthy your endpoint is, right? So whenever we talk about trust, then the ownership of the data comes into picture, right? And this ownership in technical term is called provenance, right? So you can create the graphs. So for example, this graph belong to say Microsoft and this graph belongs to Google, so on and so forth. So it can establish the ownership. So yes, that's why we can have graphs in different places having different owners, right? And finally, even if you're a single owner and you have just a single module, but you want to create different versions of the data. So as you create the data, your data is going through different versions, right? And it might so happen that you want to roll back to a different version, right? And in order to attribute the version number to the graph, you can also use this graph pattern, right? Now, the next thing that becomes important is something what we call as a filter, right? So, with this where clause, you get a set of results, right? And on top of that, you can add many other constraints, which will not be possible using this where clause. So, I just want to say something about this where clause, how this where clause and this filter constraints are different. So, in this where clause, everything you have is a subject, predicate and object. So they follow the triple form. But filter, they allow you to apply some functions or operators which are not in a triple form. So for example, let's say you have extracted a set of results. So for example, the title of the books written by different authors. Now this title of the books, they can be in different languages, and what you want as result, the titles that are written in English language. So there you can apply a function over the titles that you have extracted in the result set using this where clause, and this filter, this function filter or the language filter will give you the list of titles which are in English, and you can do many other things, right? You can do arithmetic, you can do comparison, so there are Boolean operators also, right? Now I'll now focus on something what we call as aggregation, right? So let's say you have something like this. You have some requirement like this. So you have the countries in the world, and the population of different countries, right? And what do you want? You want that you want the country with the maximum population. So here you are applying one aggregation. You are aggregating the result for different countries about the population, and you are trying to select the maximum, right? And you can also want to know what is the sum, what is the average, so on and so forth. And on top of that, you can say that I want to list down the countries which are having population less than say some value. So for that you can use something which we call having, right? So all these things we will be talking about in detail, but here I'm just giving you a bird's eye view of what we are going to do. So finally, I think the other important thing that will be going under the hood when you are processing one SPARQL query. So as I mentioned earlier, it is a language. SPARQL is a language, right? So as it is a language, it has got a grammar, right? Now, whenever you put a query to the database, now what the database does, it looks at your query and processes this query to see in the first place whether your query is syntactically correct as per the grammar of SPARQL, right? And then it tries to understand what are the kind of say graph patterns you have used, whether this is optional, whether this is union. If the clauses are put into optional thing, then what would be my result set? If they are put into union patterns, what would be my result set? Definitely that will be different from the optional graph pattern. So all these decisions, they are made by using this query algebra. So this language query is translated into a corresponding algebraic form, and this algebraic form is used to compute your result set. So this helps in computing the result set, right? So more or less, these are the things we are going to study. So uh, mm, this is going to be very interesting. So we'll be working with two endpoints. So these are the two, I guess, the two biggest endpoints which are publicly available. So one is DBpedia, and the second one is Wikidata, which is coming in a very huge way, right? So you can think this to be a parallel like Wikipedia. So Wikipedia is a crowdsourced article creation platform, and Wikidata is a crowdsourced structured data creation platform. And DBpedia is a kind of structured data repository which harvests data from the info boxes that you can see in the Wikipedia pages and put them into an RDF structured form. And both of them have got the SPARQL endpoints, and there you can query. So whatever examples I'll be showing in the first phase, they will be entirely with DBpedia, and then we will move to Wikidata because Wikidata has got many other interesting features. So so let us now start talking about the SPARQL language. Now, as I have mentioned earlier, SPARQL is a protocol and as well as a query language. So it is the query language for resource description framework. It is declarative. So you are just saying whether the triples are true or not, whether they are or not. So that's why it is declarative. And it is entirely based on the RDF data model that we have discussed in the earlier lectures, right? Uh, SPARQL query. So whenever you put a SPARQL query to the system, most of the systems, they provide results in different formats. So for example, it can provide results in HTML format. It can provide results in, say, JSON format. JSON format is becoming very popular nowadays. You can have results in the XML format, and in many cases it can provide the result in RDF format. But I'll see that I'll talk about this HTML and JSON based formats of presenting the data, right? And finally, as I have mentioned earlier, that SPARQL is a protocol for RDF. So it is a protocol for transferring SPARQL queries to the SPARQL endpoint and getting back the results from the SPARQL endpoint, right? And basically, the SPARQL endpoint is the kind of web service that follows this protocol. So you have something like this. So you have a graph which is maintained by a database, and you have an endpoint. So this is your SPARQL endpoint. SPARQL endpoint. The query will be coming here. So the SPARQL endpoint is a kind of web service which will process the data as per the query specification and then create the result and send back the result to the client end, right? So whenever we will talk about this later, of course. So this SPARQL call has got three parts. One is the base URL of the endpoint, service endpoint, right? And then followed by the query. So it is followed by the entire query, right? So this is transferred to the uh, mm, server end using HTTP protocol, right? So this is the book we will be following. So this is a very nice book, very lucidly and nicely written book, which is called Learning SPARQL. And there are plenty of tools. So one tool that I like to use in my demonstration, but you are free to use other tools as well. So this tool is called Apache Jena ARQ framework, right? So this is a Java library. You can write Java program to process SPARQL query and provide get answers to the SPARQL queries. We'll see shortly how we can do that. But also you can query directly to the SPARQL endpoint. So these are the two important endpoints which will be kind of bread and butter for us for few lectures going forward. So this is the first one is the SPARQL endpoint for DBpedia, and the second one is the SPARQL endpoint for Wikidata. So then let me talk about the command prompt way of writing the or processing the SPARQL query. So if you install this Apache Jena, the installation commands and this manuals they are given in the website that I have provided. So if you have configured it properly, you go to the command prompt and the proper directory, then you just say sparkle.bat. I'm doing it for Windows, but you can also do it for Linux. So you just need to put two things. One is the data and other is the query, right? So it will try to process the query based on the data you are providing here as the argument, right? Also, you can execute query from Java program. So we'll be demonstrating the execution of the queries from the Java program, but you can do it from other languages like Python, right? So let me give you a quick demonstration of, okay, maybe let me continue with the slides, and then as we move, we will go to the respective